Hi, this is Dr. Tech recording the lecture of ciss342 for the topic of file-based encryption. This is the topic in Moodle, and what I'll do is I'll just kind of read the notes and also go through a few examples with a virtual machine. So the first thing is we will switch to the note here and take a look at the note itself. So GPG stands for GNU Privacy Guard, which is a play on the name of PGP, which is a non-open source product, which is pretty good privacy. GPG is, as all GNU products, it is open source, and there's no need to pay any money. It's free as in free beer, and also free as in freedom, which means you can look at the source code, make changes to it, and also distribute the changed versions. In order to use GPG, you have to install GNU PG. So it's not, the package name is not GPG itself. It is GNU PG, GNU PG. So let's go to the virtual machine. Let me see. Okay, that's the virtual machine right here. Let me log in as root. I can't remember my root password. Okay. Well, wrong prompt. Okay, do it again. And we logged in as root. Now, it should be noted right here that since the beginning of the semester, we have been encrypting the entire partition, which is cool because if you look at the mount points, it's basically saying that everything that is inside the mapper, which is a LVM construct, my home folder, everything in home is encrypted, everything in temp is encrypted, everything in USR is encrypted, everything in var is encrypted. The important ones will be home because that's where you put your own personal data. var is also extremely important because if you have any type of database or web server, a lot of files and data will be stored in /var. But not only this, if you look at fstab, you will also see that our swap partition, which should be somewhere here, our swap partition is also in mapper, which means the swap partition itself is also encrypted, which is also kind of important because otherwise, someone can take a look at the remaining content of the swap partition, and they can still get a lot of information about the application that you run and also the data that is associated with the applications. The only part that is not encrypted, according to this, is the boot partition, which is fine because the boot partition has a very small kernel, which is very common, and there's no secret to that particular kernel. But everything else is encrypted. I cannot overemphasize the importance of partition-based encryption over file-based encryption, because when you have the entire partition encrypted, someone can get a hold of your computer while it is not running and extract the hard drive, and unless they have a lot of processing resources, your data will still be safe, and that's a pretty important feature if security is on your mind. But since this topic is about file-based encryption, we'll go ahead and continue with this approach and install GNU PG. So here we are going to download the package from okay, maybe I did not type the name incorrectly. GNU PG. And did I install GNU PG? Yeah. And yet it's complaining that no package will be installed. So either it is already installed or, well, that's one way to check. So we can go into aptitude in the interactive mode and then look for GNU PG, and it is already installed. Okay, so it's already installed as a base setup of the operating system, which is cool. So that means we don't have to reinstall it. Alright, proceeding to the next page. This page talks about the basic idea of key pair encryption. With key pair encryption, you have two keys. One key, it really doesn't matter which one which you call a private key and which one you call a public key, you just have to designate one as your private key. The main concept of key pair encryption is what you lock with one key can only be unlocked with the other key, and vice versa. So that means if you keep one as a private key and one as a public key, you can distribute the public key to the world so that everybody can encrypt content to send to you. But only you have the private key, which is the other part of the key pair, to unlock the content. So that means, let's say you have two people who want to send you email, person A and person B. So person A can encrypt the email using the public key of yours and send an email to you. Person B, with your public key, can intercept the email, and the public key cannot unlock content encrypted by the public key itself. So that's why it is okay for everybody to have your public key, and they can see each other's encrypted transmission, and they won't be able to unlock anything. And you being the only one with the private key will be the only person who can unlock the content already locked or encrypted by the public key. So that's the cool part of key pair encryption, is the key itself, or the public key itself, is no secret. You can distribute it to anyone you want, or to the whole world, so that everybody can send you encrypted messages. Okay, so that's basically the content of this page. We'll move on to the next one. We want to generate a key pair. And this is the command to do it: gpg _gen key. So we'll go back to the virtual machine and run the command. Let me switch to a user first. Let me see who I can. I don't have any user installed on this machine. I guess it's. Let me just add a dummy user here. Okay, I will just use Bond. Okay, so now I can change user as Bond, as a regular user. And I'll go through gpg gen key. Now you will find out that right now it's not easy to do it. The rest of the slide talks about the key type, and right here DSA and algamol is the best option. So we'll just press the enter key to accept the default. And then the next slide talks about the length of the key. 2048 is really quite long for all practical purposes, especially for personal use. That's more than sufficient. The longer the key, the more time it takes to encrypt content, so you have to keep that in mind. The next one talks about the expiration date, and if you don't expect it to expire, you just press a 0. Okay, so we press a 0 here when you confirm everything is correct. The next slide talks about user ID, and typically you want to enter your email. Okay, you want to enter your real name and then your email as your user ID, and this is also indicated here by the example. So you have the real name, comment, and email address in this form. So in this case, I'll say James Bond 007, and the email address. It doesn't have to be a real email address. It's really just an ID, so that the key tracking mechanism can say, okay, to whom do you want to encrypt the content? And that's the whole concept. So we can just say Bond at, I don't know, is it MI5? The organization is called MI5. Well, just make the assumption that it is the case. And I think Great Britain, GB, I guess .gov.gb for Great Britain. I'm not sure whether that's the actual subscript. But, since I won't remember this particular email address, we'll just say bond at drtech.org. Okay, that way I can remember. Okay. Invalid character in name. I wonder if it's the 007. Nope. So this part, oh, this part is just the real name. Okay, never mind. I never read the prompt itself, so never mind that. So it's James Bond, and then the email address is bond@doctotech.org, and comment is 007. There we go. So everything is good. Type O for OK to go, and then we can enter a passphrase, which is optional. Okay, so we are moving on to the notes here. The passphrase is optional. In the event that your private key is exposed, the passphrase is the last resort, the last defense against your encrypted content getting stolen. So it all depends on whether you want to do it or not. It doesn't have to be like that. In other words, you don't have to specify a passphrase for the key pair. It's a good idea to do it, because just in case your private key gets stolen, then the other person will still need to know your passphrase to get to it. So we'll go ahead and specify a passphrase here, and not enough random bytes available. Please do some other work to give the OS a chance to collect more entropy. Great. Okay, so what I'll do now is I'll just go ahead and try to emulate, some disk activities. The way to do it is to type Alt F2, and that will give you to one of the other text login prompts. So I'll log in as Bond, and then we'll do some activities here. Something that involves I/O will typically generate more randomness. So we can do something like this. Now this is really, well, I guess let's see if we can do it. We probably cannot do it as Bond. Okay, let's log out and log in as root this time. Okay. You have to be really careful when you log in as root and do something like this, because it can potentially do a lot of damage. I'm typing Alt F1 to switch back to the first one, and we still need some more random bytes to do something. So we'll go ahead and do some operation here. This one is really dangerous, so I do not recommend anyone to do it. DD is it's a very can be very dangerous. So I can specify the input file to be HDA, and specify the output file to be /dev/null. So what this does is it's copying the entire hard drive A to basically nothing, to a black hole. But what it does at the same time is it generates I/O events, which helps to randomize bytes and whatnot. So let me press Alt F1 to switch back to the first prompt, and it is still complaining that we don't have enough randomness. Fine. Okay, so this is not doing it. I just type Control-C, and instead of doing this, I can install an additional package. So I'll go to Aptitude, Install. I think it is called GPM, which is a mouse for text mode use. Okay, it is the right name. Very good. Okay. And I'm just moving the mouse here. You can see I have a mouse cursor even in a text screen. And that's basically what GPM is for. It's basically allowing you to use a mouse in text mode. It's not really useful for anything other than just creating random events, and I'm just moving my mouse randomly in this text screen here. And let me switch back to Alt F1, and we are all done. Okay, so we have our key generated, and we can now move ahead in the notes, go to the next page, and this one asks where are the where is the key pair kept. Okay, so what we'll do is ls, and in this case, if you do an ls, you won't see it, simply because it is called a hidden folder. Anything or any file name or folder name that starts with a dot cannot be seen with ls. you have to use ls-a to see all the hidden files. And here we have a file called .gnupg, and it is not a regular file, it's actually a folder because it is in blue. So we can go there or just do a ls-l with the name of the folder, and we can see all the files are here. Particularly we have pubring.gpg, and that's where all the public keys are kept, and secring.gpg, and that's where all the private keys are kept, and that's the file that you want to keep as a big secret because that's where the private key is kept. Oh, and let me switch back to here. You can also see that, in terms of permissions, group and others have no permission whatsoever into the folder or into these individual files. So that's a good default protection because you definitely don't want people to have access to your GPG keys. Alright, so we are done with section 4 and we are now moving on to section 5. Section 5 really just talk about the easiest way to use GPG, which is basically using the -e option to specify I want to encrypt. By default, it encrypts from standard in, which means you can redirect a file into GPG and redirect the output to a file to capture the encrypted version of the file. But this will interactively ask you to whom do you want to encrypt the file for, and it will look up the key ring and find out who it is supposed to encrypt the file for. Let's just go ahead and do it, and so I can show you exactly what I mean by that. So here, let's say that we create a folder, okay, missions, and we'll go ahead and edit a particular mission, goldenfinger.txt, and I cannot remember exactly what that movie is about, so I'll just say I cannot recall. That definitely should be a big secret, because if I were James Bond and I forgot about what the mission was about, definitely don't want other people to know that. Okay, so now we run gpg-e to mean that we want to do encryption. Redirect from the file missions.goldenfinger.txt, and then redirect it to missions goldenfinger.txt, and I typically just add an extension of encrypted or something like that to remind myself that the file is encrypted as opposed to the original one that is not encrypted. And when I press the enter key, it asks me for the user ID. The user ID is the email address. So in this case, it is bond@doctortag.org. And since that's the only recipient, I can end with an empty line. In other words, I just press the enter key, and now we have the encrypted version of that file. Let's go ahead and take a look. ls-l missions, and here we have two files. The first file is the plain text one, and the second one is the encrypted version. You can see the encrypted version is quite a bit bigger, and that's because the encrypted version, especially with short files, you cannot have the encrypted version have the same size, because otherwise it will just be easy to crack the encryption scheme itself, and that's why it gets a little bit bigger. If the file is already large, you won't see a increase of size as much. Okay. The next line here talks about how we can specify a particular recipient using -r so that it does not ask you, which is really great for batch files, because if you want to periodically use a batch file to encrypt certain things, that's the way to go. And we can definitely try that here. So in addition to -e, we say -r, and then we specify who we want to encrypt the message for, and that's it. It doesn't ask you interactively. Now note that when you are encrypting a file, it does not ask you for a password, because it doesn't make sense, right? I mean, if you're just encrypting something, a file for somebody else, why do you need to specify a password to encrypt? It's the deciphering or decrypting that needs to be protected, and that's in the next screen. When you decipher, you can say gpg-d D for decryption or deciphering, and you can use redirect like this to redirect the input file as the encrypted version. And if I don't want to type the encrypted file to the output to the screen, I can also use redirect to capture the output into a regular file. So let's go ahead and try that. gpg-d. In this case, we have missions.goldenfinger.txt.encrypted, and this time I will just show it on the screen itself, because the file is so short, it doesn't really matter. So I won't redirect the output to a file. I press the enter key. Now, as soon as you press the enter key, it actually knows that the file is encrypted for James Bond, because when we do the encryption -E option, we specify it is for James Bond. So right now, it asks me for the passphrase of this particular encryption key. And remember, this part is optional. If you don't specify a passphrase, it will just go ahead and find the private key and decrypt it for you. But since I did specify a passphrase, and right here we have the content. Oops. Right here, I cannot recall is the content, the decrypted content of that file. I did not save the content, to anywhere, in this particular system because there's no need. Okay. So this slide talks about, how do you want to manage the private key. Okay, there are several things. One is you definitely want to specify a passphrase if you think your private key may be exposed, by accident, or it's just no way that you can safeguard your private key. So definitely want to specify a passphrase. And the second thing is, this part here, any administrator of a system can steal your private key file very easily. Okay, and that's why in general, if you don't trust the system administrator, it's not a good idea to put the private key in the system itself. There's really no way to protect against the administrator of a system, because if you put it onto a USB thumb drive, the moment you plug in the USB thumb drive, the system administrator can read all the content on your thumb drive. So if the private key file is on the thumb drive, the administrator can read that right away. If you specify a passphrase, the system administrator can install a keylogger, a software keylogger, so that your passphrase can also be captured. So there's no way to get around that problem. If you have a system administrator that you cannot trust, you just cannot do anything on that computer for deciphering. So I hope that's somewhat clear at this point. Whether you really have that much privacy when you cannot trust the system administrator. The next slide talks about how to apply GPG. Although GPG supports strong encryption, it only protects privacy when applied correctly. Particularly, the private key and the passphrase must be protected. It sounds easy, but it's really not. So this part really talks about the stuff that I have talked about a little bit earlier. Now, what if you need to decipher files or messages sent to you on the go? In other words, what if you let people have your public key so that they can encrypt messages sent to you? If you're going to use a computer that you cannot trust, or the administrator of the computer you cannot trust, you don't want to expose the private key on that system at all. Okay, so that's basically, it's just a big no-no. You want to bring your own computer and use that for deciphering. In other words, you just hook up your computer to the hotel network, get the encrypted messages, and then use your own computer to decipher the messages. Because anytime you plug in a USB thumb drive with your private key into a system, it is going to be exposed. And there's no way to get around it. Okay, it's just no way to get around it, regardless of the operating system. It doesn't have to be Windows, doesn't have to be Linux. It's just that you cannot trust. If you cannot trust the system administrator, there's nothing you can do on that system that will give you privacy. Okay, so let's go back to the notes. Go to the next slide here, and we have just a few nifty commands to do stuff. This one combines the tar command to the encryption command. so that we can create a encrypted version of the tar file on the fly, which is kind of cool because there's no unencrypted tar file in between, because it's using the pipe operator. Let's take a look at this command here. This is the regular tar command, but I specify the dash symbol here, which means standard out as the output. So that makes it possible to take the output of this command and feed it into this command here. And this bar symbol is basically the key to take the first command, the output of the first command, and feed it as the input to the second command. This is my second command here. The output of the second command is redirected using the greater than symbol to this particular file here, folder.tgc.encrypted. And this is a really handy command. And the next one is a handy command to reverse what we just did. Basically, this time we have to decipher the encrypted file first, and then send the output, which is the decrypted content, to tar again. And this time we use X instead of C. C stands for create, and X stands for extract. So this time we're extracting the content of that tar file, and just reconstitute the folder, the files, and whatnot inside the archive file. So these two commands are pretty nifty. They combine a lot of the they combine the most commonly used commands like tar and gbg into one single command line. So that's pretty much it, for file-based encryption. The next slide, or the next topic, talks about SSH for remote access. And here we have, it's pretty easy for the most part. We have already used SSH in a way. This part talks about, how you should, if you have a production system, you should go to the folder, the configuration file called /etc/ssh/sshd_config, and turn off root login. Because anytime you allow someone to log in directly as root, that's a big exposure. If you don't allow root to log in, then a hacker has to first guess what is a valid username, which helps to kind of obscure the rest of the hacking, because it makes it harder for people to even guess, okay, who is a valid user. If you turn on root login, then everybody knows, okay, we'll try root first, because root is always there, and two, it is an administrator account. So that's why you want to turn it off if your machine is going to be exposed to any type of network. In a virtual machine, we never bother to do it because, it's a virtual machine only for exercise purposes. But in the real world, this is what you need to do. Okay, so what we want to do is to get back to the root account here. I can confirm who am I is root. You go to etc/sshd_config. Oops. And I think I have not installed SSH server on this machine, so let me install that first. Okay. Aptitude install open SSH server. Yep, I have not installed a server of SSH on this system yet. And now it is installed. Alright, so let's go ahead and take a look at the file. And we want to look for root login. And to turn it off, you just say no. Okay. And once you do that, you have to refresh SSH, the SSH server, because otherwise, the change is not effective right now. How do I know? I can see if I can do it, because I can say SSH localhost, and it will ask me, do I want to log in as root, and ask me for the password. I type in the password and I log in as root through SSH. So that proves that the change was not, has not become effective yet. To make it effective, you type /etc/init.d/ssh restart, and every time you restart it, it will reread from the configuration file. So this time, let me try to log into localhost again. Ask me for the password, type in the password, and permission denied. So that's exactly what I want, because I want the system not to let me log in through SSH, even if it is from localhost. So that's good. I just confirmed that this part works. The next part talks about authentication. The first one is password authentication, which basically is interactive authentication. The next slide is a little bit longer. It has to do with public key authentication. This is really kind of cool because it makes the system so that it does not need to ask you for the password to log in. So that makes it possible to use SSH in an automated script to log into another system to perform certain functions. So that's kind of handy for that sort of thing. So let me go ahead and illustrate how to do it in this particular system. So we'll go to bond, and we'll execute the command ssh keygen, and we can just accept the folder. The default folder is fine. That's exactly what we want. And this time we don't want any passphrase, because if you specify a passphrase, it just defeats the whole purpose, which basically means you cannot use automated SSH in a script. So this time we'll just press enter for no passphrase. And here we have the key file generated. Okay, so let's go ahead and take a look at that folder. .gnu-pg was from GPG. .ssh is from SSH keygen. So we'll go ahead and take a look at .ssh, and you can see that it has two files. The first one is a private key, and that's why it is protected from everybody. The second one is a public key, so it is not protected. So what we'll need to do is to create a file called authorized keys that has all the public keys that are acceptable. In this system, since I only have one single computer, it kind of makes it harder to illustrate the point. So what I'll do is I'll just go ahead and copy .ssh idrsa.pub, which is the public key, to let me change it from cat, and greater than is kind of like redirect, except it is appending to the file that is going to accept the output. So I'm appending this to .ssh, and the file has to be called authorized keys. Okay, so this name has to be exactly spelled like this, authorized keys. If I had this file already, it would just append additional items to it. If I do not have this file existing yet, it will just create a file. So now that I have an authorized key file, I can try to log in and observe this. Okay, if I say SSH localhost, if you don't specify who you're logging in as, by default it is the username that you are currently as, which is bond. In other words, it's the same as SSH bond at localhost. Now observe this. Press an enter key. It asks me for to make sure that I can cache the the fingerprint, and it does not ask me for any password, because this is called the public key authentication method. And that's great, because what we can do now is we can say SSH bond at localhost. Now remember, I'm just doing this because I only have one machine, which is localhost. So in reality, you can replace localhost with the host name of somebody else. You can say power at arc.lostreals.edu, as long as the bond home folder on power has a .ssh folder, and inside that folder it has authorized keys, which contains the public key of bond. It will still work. Okay. Well, I suppose I can just illustrate how to do that here, because I can actually access power from the virtual machine, because it's using the host operating system as a bridge. So let me just show you how this can be done. It's going to be a little bit interesting, but I think we can do it. So what we'll do is I'm going to type. Okay, cat is basically typing a file. So I'm going to type my, inside the virtual machine, my SSH ID RSA.pub, which is the public key. But I'm not typing it to the screen. Instead, I'm feeding it to the command SSH. And you can do it. This is a really, really kind of cool feature of SSH. And this time I'm going to authenticate to my account on Power. And in addition to this, I can specify a command. In other words, I'm not logging in interactively. When I log in, I want to run a command, and that's it. And the command I want to run is to cat whatever file, whatever content is piped, or whatever content is specified to SSH. I want to take that content and concatenate that content to the .ssh folder / authorized keys. Okay, so this is really cool. Just take a look at this. It will ask me, to enter the to let it store the fingerprint of the Power server. Okay, type yes. Enter my password on Power. Press the enter key, and the command is done. Okay, it's completed silently, but it is done. So now the second thing I want to do is to see if I can remotely run the command on Power from the virtual machine using SSH, but without having to specify the password. Okay, that's what I want to do. So let's go ahead and try it. We say SSH, my account name on the Power server, and just give it a command. Doesn't matter what it is. Who am I? It's fine, or host name, or something along that line. It's fine. So I'll just say, who am I? Okay, because on the virtual machine I do not have the account called Bond. On Power I don't have the account called Bond, and on the local machine I don't have an account called AUYUNT. So if I type who am I know exactly which system I ran the command from. So press the enter key, and this is the output. In other words, this is proof that I can log into my account called AUYUNT on the Power server and run the command called who am I without having to specify the password. So that means I can take this command here, stick it into a script, and have the script run periodically. And the script will run just fine because it does not require any type of interaction to enter a password. So that is a really cool use of SSH. You can use it in a script to remotely control or run commands on another system. But when you do that, you have to be careful, because if you have elevated privilege with the remote account, you have to make sure that that account is properly protected. But it does give you a lot of options. In other words, I can look at the amount of points on Power just by running this command here. And these amount of points are actually on Power itself. It is not on the virtual machine. So it's a very handy way of doing things. And remember, with SSH, everything is encrypted. So that makes it a very powerful technique. And you can even mix and match SSH with GPG. In other words, I can create a GPG encrypted tar file on Power on the fly and capture it with the local machine. So that way I can do a remote backup of certain things on Power and have everything transmitted. Not only SSH itself is encrypted, but the file itself is also going to be encrypted. So even if someone can crack my SSH encryption, they still have to crack the GPG encryption on the file itself. So that's like double insurance when you're trying to download a archive file from another system. Okay, well, there's no end to what we can use this type of command for. So I'll just kind of stop here, and call it a day, because it is kind of late right now. Let me check the time. It is 1:53, and I have to wake up a little bit early tomorrow, so it's time to sleep. And that's it. Okay. Well, I hope this is helpful. I think this is I guess this is what a hybrid class is about. Because I have the lecture online. Um, and I'll have some activities for you guys. For the GPG topic. Nothing really that major because you have already seen all the commands that you can do, and there's really not much to it. It doesn't have a lot of theory to it, like the permission part from the previous topic. This is just a preview. The next topic is about client-side operating system services and optimize. Okay, I think we just want to talk about antivirus. For this part here, this part here is not exactly describing what we want to talk about. Yep. So it's kind of cool too. Linux has some really interesting way um, to scan for virus. That's not the tricky part. But to create a file system that can scan for viruses in the files on the fly, so that you cannot access a file that is infected. Now that is kind of interesting. So that's for topic 5, and we'll talk about it, I guess, on next Monday. Alright, I hope this is helpful, and good night.